Hi everyone, welcome to this latest video on building your own pedals with a load cell. So in this video I wanted to take a quick look at back at the Arduino and the programming. I spoke about using Hall effect sensors for the throttle and the clutch. I've also been listening to your comments about the trials and tribulations of using the HX711 load cell amplifier, and also some of the people that have been asking questions about how you use a 3-wire load cell. So in this video I'm going to try and show you something that links the different types of input with regards to the Arduino programming, and show you a bit about the calibration. That way hopefully it will tie up some of the information. I'm also going to show you a little electronics board that should solve some issues with different types of load cells and making them easier and better integrated to our Arduino and our use for pedals. Okay, so the most common type of input for sort of cheap consumer grade pedals is a potentiometer. You'll also potentially find this interesting if you're building a steering wheel and want potentiometers on it. You can make paddle clutches, you could make hand control brakes if you wished. So potentiometer has 3 output pins. Either side are positive and ground. They can be either way round. It just depends then whether or not positive values or negative values as you turn clockwise and anti-clockwise. So positive and ground on the outer pins, and your data or your resistance is on the middle pin. So your data, as far as the Arduino is concerned, is on the middle pin. So I've got a little breadboard here. If you're not sure what a breadboard is, it's for making things easy for prototyping. So essentially, try and zoom in, either side you have some channels or some pin holes. They're all connected vertically and they're marked plus and minus. So in this case I'm providing a 5-volt power down this red channel and ground on the minus channel. So anything I plug in to the vertical series of holes will be positive on the right hand side, negative on the left hand side, and then these ones in the middle are connected horizontally. So this wire is connected to the A0 pin on the Arduino Pro Micro. So anything I connect in the horizontal row will make the circuit with this yellow wire. So this is my data in from my sensor. This is my 5 volts and this is my ground. So if I connect the throttle, if I connect the potentiometer, so ground and ground and 5 volts, and then collect my value on that pin. So this is the sketch, the same sketch that we used in the earlier video. It's a modification of one provided by Am Studio. Give their channel a look because he does some interesting DIY stuff. But essentially, let's just have a quick look. I've tried to annotate this sketch as much as possible. I'm no expert on this programming language, but I'm starting to understand it more. We have to include the joystick library. If we include the joystick library, we get access to all of these different features and axes, but most importantly it connects the Arduino as a gamepad to Windows, so it makes life easy. We've got here 7 axes set up, X, Y and Z, and then the rotational axes, the sort of gamepad type rotational axes that you expect to see, and then the throttle axis. If you want to comment out anything that you're not using, you just put 2 forward slashes in. So at the moment I've commented out all the axes apart from the throttle axis. So here we've got 3 lines of code. The first one gets the analog value from pin A0, which is the data pin that I've got soldered onto the Pro Micro board. This one maps the input from the analog input and outputs it as a digital value, and then this last line sets that value to the throttle axis value that it passes to Windows. I've commented out a line here which is a serial print, which if you go to Tools and Serial Monitor will give you a live data feed of what's coming out of the sensor. So what we'll do, I'll just show you that. If we upload the sketch to the Arduino, then we run serial monitor, we've got our value, and if I twist so at one end of the scale the potentiometer reads 255, it's the maximum value, and then at the other end of the scale it reads 0, the minimum. So if I close that and then open in devices and printers, we'll see our Arduino Micro show up. If we right click and go to game controller settings and then properties, we get this test page, and if I twist my potentiometer we can see the throttle axis slider working. Now you'll see it's all jumpy at the moment, and that's because it's not calibrated. Just cancel. Now I've shown this program before. This is DI view. This shows you all the axes connected to the computer, and it gives you the ability to calibrate them. So at the moment it's not calibrated correctly, and this is calibrated for the third of the things I want to show you in the video, so I'm not going to change that calibration for now. What I'll do instead is I'll go back to the sketch, I'll comment out the throttle axis, and we'll put this potentiometer onto a different axis. Let's put it on the rotational y-axis. And again, we need to change this pin to be A0. Upload the sketch. So now what we should see in DI view, you'll notice over here now the rotational y-axis is now getting the value of my potentiometer. And if we go back to the Pro Micro, so right click, game controller settings, properties. Now see a nice smooth slider, because this one's calibrated to the values of the potentiometer. Okay, so the next thing is this Hall effect sensor. Might want to do a little bit of research on Hall effect sensors just to understand a bit more about them, but essentially it can detect the presence of a magnetic field. So you have a magnet here. As the magnet comes closer to this little black sensor here, then this board will output a value, but it essentially clones a potentiometer. So our sketch will see this as the same input as this, and that's very handy because it means any sketch that we've got, any prototype or any sketch that we find online for working with these, means we can quite easily swap to using these, or we can upgrade our Logitech pedals or things like that. Okay, so to prove the point, I'm going to show you the wiring. It's marked on the board. So the first pin is A0, so it's the analog output. Next is ground. Next is your 5 volts in, and the last one is a digital pin. That digital pin just goes between 0 and 1, so you can use that as a proximity switch, like an on-off switch. But obviously for what we're doing we don't need that. So my ground wire, 5 volts, and my signal. Now hopefully you can see that again it needs calibrating, but as the magnet comes closer and further away, the slider on this axis is sliding. It's quite a good range. I was shocked at how far away the magnet can be and still influence the sensor. But hopefully you can see how simple a change that is from a potentiometer. Now the third thing I want to show you is back to the original reason for doing this video series, load cell. Now if you've been following along and trying the previous parts of the video, you know that when you buy these they come with an HX711 load cell amplifier, which has got I believe an analog to digital converter on it, but they're quite slow and temperamental, and the sketch program that you need to write is sort of based on a library for the HX711. I think you can only use one HX711 amplifier on each Arduino board. I think there is a multiple load cell library, but I haven't found any one that uses it or knows how to use it properly. And so if you want fast reading and you want to make your load cell act like a potentiometer, this is the board you need. So I'll put the link to it in the description. It comes from a company called Leo Bodnar. Okay, so the easy thing, so hopefully you can see the wiring here. So the only unfortunate thing about it is it doesn't use the same terminology as the wiring for the HX711. So here we have the red wire is 5 volts, white is termed positive in, marked positive in on the board, green is marked negative in, The yellow is a shield cable and black is a ground, and you connect those both to the ground pin on the board, and these are just the little screw connectors. And then on the output, just like the potentiometer, we have ground, we have signal, and we have positive 5 volts. Now I need to change the sketch back just because because these are 100 kilo load cell and I can't twist it with 100 kilos in my hand to prove this. Calibration is fairly tight, the values are very small range of values. So I calibrated it earlier. It just means that I need to switch back to the throttle axis, because that's the axis that I've calibrated with this load cell. So again, I'm going to comment out the one that I was just using. I'm going to delete the comment, the forward slashes for the axis that I want to use, just so that brings that back in. Upload it. Okay, so commented out the rotational axis that I was using, deleted the forward slashes on the throttle axis, so that's back in play. Upload to the Arduino. Actually, if I bring the serial print, uncomment that so that we can use that, I can just show you then that the load cell is reading values by once again demonstrating it on the serial monitor. So it says 0. If I give it a twist, I start getting values. Then if we go back to DI view, if I give the load cell a little twist, it's easier said than done. You can see the slider moves. Okay, so hopefully you understood where I was going with that. So basically these three things now work the same as far as the Arduino board is concerned. I think that makes things a lot easier for us. This little load cell amplifier from Leo Bodnar solves all our problems with the HX711, so I'm going to be using that going forward. You can use more than one of these per Arduino, because you can use as many of these as you have analog pins available on the Arduino. So this is how you could easily have all three pedals with a load cell. If you've got, which is the other comment or other questions I've had previously, if you've got a 3-wire load cell, the type that I used in one of the earlier videos, Leo Bodnar do a converter, which is an easy way of turning 3 into the 4, which can then go into this amplifier, so you can use both. Okay, so thanks for watching. I'm going to be doing obviously more videos in this series. I'm trying to catch up at the moment with videos on the pedal design, so please check out the earlier videos, and so thanks for watching. Please subscribe to the channel. I'm getting very close to the 1,000 subscribers now, and like the video. Please leave comments. I like interacting with you all. Feels really good when people ask questions and we can solve issues, and obviously that gives direction for where we can take this video series. So until then, thanks for watching.